Hey everybody, welcome back to another session from the Net Academy. On this session what we're going to be doing is going into more detail, a deep dive into the LSA or link state advertisement types 4 and 5. We're going to go through the very beginning, what their names are, what they do, and how you can actually see these different OSPF or Open Shortest Path First LSA types in a Juniper Junos environment. So let's get going. And so here's the network that we've been using for the last few weeks. 2 weeks ago we had a deep dive session on types 1 and 2. Type 1 being the router LSA, type 2 being the network LSA. Here's the link, it's also in the comments bar if you haven't watched it already. A week ago we had the deep dive session on the type 3 LSA. Again, here's the link, it's also in the comments bar. But this week we're going into that type 4 and 5. The type 4 being the Summary ASBR or Autonomous System Border Router LSA. The type 5 LSA is the External LSA. But what does all that mean in actual English? So we're actually going to go through not type 4 first, but type 5 first. And then we're going to cover what the type 4 is and why it's actually related as such to that type 5 LSA. Okay, so you can see if you've watched the other videos, you can see there's a slight addition now. There's a slight difference to this network. What I've got here is these new entries, this 192.168.101 or 102 or 103.0/24. That is because the router R6, which is going to become an autonomous system border router, is going to be injecting external routes. In this case it will be static routes into the OSPF routing protocol, and that's essentially what an autonomous system border router or ASBR actually is. It's a router that is participating in the OSPF routing protocol and is actually injecting external routing protocols, whether it be static routes, ISIS, RIP, BGP, the list goes on. It's taking those routes from the routing table and then injecting it into the OSPF routing protocol. But of course, for other routers in the OSPF area or outside of that OSPF area through an ABR, they've got to learn, well, where are these routes actually coming from? Who's advertising them? What's the cost to get to those routes? And that's where the types 5 and 4 actually come into this. So what is a type 5 LSA? Well, the type 5 LSA is that external LSA. So if we look at R6 or VMX6, R6, we can see it's got these static routes connected to it. Now, nothing is really configured on R6 yet. Obviously, that's going to change in this video, and we're going to do literally everything from the very beginning. But when I then start advertising these external routes, static routes, RIP, EIGRP from the Cisco world, you could do that into OSPF, BGP, whatever it may be, then what's going to happen is R6 is suddenly going to become an ASBR, and the other routers in area 2 will know that R6 has become an ASBR, because if you remember back to that deep dive on the type 1, type 2 LSAs, in the type 1 LSA, that router LSA, every router in an area is advertising to all those other routers in that same area, this is what I'm capable of, i.e. those VEB bits. So when we inject these external routes into OSPF, two things are going to happen. One, it is going to update its VEB bits in that type 1 LSA. It advertises to R4 and R2 in area 2 to say, hey, my E bit has flipped. I'm now an external ASBR. I'm injecting external networks routing protocols into OSPF. And so R2 and R4 know, R6 is now an ASBR. But they do not know from that type 1 LSA, that router LSA, well, what are these external networks that you're actually injecting into OSPF, Mr. R6 router? And that is where that type 5, that external LSA, actually comes into it, because that external LSA is going to advertise a few things. It's going to advertise, R6 is going to advertise a few things. First, amongst all of them, it's going to advertise, well, what are the network IDs of these routes I'm injecting to OSPF? What are the subnet masks? Also, what is the identity? What is the router ID of the router that is injecting these routes in the first place? In this topology, it's simple. There's one ASBR, but in an area you could have multiple ASBRs or even more. It can happen, and so you need to identify, well, okay, these routes are coming through this ASBR, but I've got more routes coming through another ASBR. You need to identify, well, which ASBR is actually advertising, importing, bringing in these external routes into the OSPF, and that's where that type 5 LSA would do that, because it's advertising who that ASBR route actually is, i.e. who's advertising these routes. It's also going to do other things as well. It's going to advertise the cost, so the ASBR's perspective of the cost to get to those external routes, and he will then advertise that to all other routers in the same area via that type 5 LSA, and he will also advertise the type of metric. Yep, in OSPF there's different types of costs. You've got E2, E1, N2, N1, and you've got intra-area OSPF costs and inter-area OSPF costs. There's going to be another video where we're going to be going into those different types. But that type 5 LSA, you can see that's actually doing quite a lot. So let's get onto R6 and actually configure it now. So here we go on R6, and there's really nothing configured on here. So the first thing I want to do is give it a router ID. This is very important for OSPF, or for any routing protocol for that matter. So if we do set routing options, router ID, and we'll give it 6666, R6 of course, and that's going to be one of the first commands. And so now I've got the router ID set, I now need to start configuring a little bit more. Now I want R6 to communicate with R4, obviously to allow the OSPF adjacency to build, and even just to do a basic ping. So what we have in the Junos world is a set command. That's basically saying I'm going to set a configuration. I'm going to set a configuration in OSPF on an interface or for some kind of filtering, firewall policy, whatever it may be. It is a setting of a configuration. And now I need to set it to the interface of gigi 0/0/1.0, that's unit 0, or sub interface 0, it's the same thing. And now we say family INET. What we're doing here is saying that it is a layer 3 interface. You can do family Ethernet switching or family bridge because it's a router, but that's really saying it's a layer 2 interface. If I do family INET, it's saying this is a layer 3 interface and it's using the Internet Networking Protocol, i.e. IP, Internet Protocol. And then we give the address 10.0.1.6/30. Brilliant. Okay, now that's the interface set. We've got the router ID set. Obviously there's a lot more that we still need to do. So let's go into edit. Edit is a way of navigating around the Junos interface within the Junos command line interface, and there's a hierarchical tree that you basically learn as you're navigating through. So if I just do edit and question mark, you could see there's loads of different branches of this tree, because I'm right at the top here, just in edit here. There's loads of different branches you can actually go down, but we want to go into edit protocols, do question mark again. You could see all the different protocols that are in this virtual MX router, but of course we want to focus on OSPF. So if I do edit protocols OSPF, you can now see it has changed to edit protocols OSPF. So I'm now in the OSPF protocol, and now I need to do set. I need to configure a configuration for R6. Now first we could do set area 2. You can do set area 0.0.0.2, but I typically just do set area X, in this case area 2, and then we need to assign it to an actual interface. So here we're going to say you're going at gigi 0/0/1, and again, as I've said in previous videos, you don't have to give the unit .0, it's just good practice in my opinion. And we're just going to enter that. If I do a show, we can now see that we have this basic OSPF configuration actually working, but it's not actually committed yet. So if I now do a commit, what that's going to do is it's going to commit everything I've just configured via those set commands. It's going to take it from the candidate configuration, and it's going to put it into the running configuration. And so that's actually just been established. So now if I do a run, this is the same way of doing Cisco's do. I'm in a configuration mode. So if you do run, I want to run ping 10.0.1.5. Let's see if we can ping the remote end. And we can. So now R6 can ping R5. That is obviously brilliant for any type of connectivity. I haven't though configured anything else. There's no static routes here. Remember that I want to advertise these routes into OSPF, but they don't actually exist yet. So if I just do run show route, you can actually see that there's no 192.168.101.102.103, etc. They simply do not exist. So now we need to configure that. So I'm going to do a set routing option static route 192.168.101.0/24. Now after this you have to give an argument, you have to give an extra command, and this is where Junos is really powerful, because now if I just expand this a little bit more just so we can see it, you can see that we can actually set it to discard. So when an external router in area 3 or area 1 eventually pings any IP address within this subnet, if I've got it set to discard, then it's not going to send an ICMP. So essentially when we do that ping, we're going to get zero response. We don't actually know if the routing is working at all. Obviously we don't want that in this lab. So if I actually set it to reject, where we are going to send an ICMP unreachable, i.e. that because the IP address doesn't actually exist but we're still hitting the subnet, R6 is going to see an external router is trying to ping my subnet, and I need to let them know that actually it's unreachable, and so therefore we are going to know that the routing is actually working. So if we actually do reject, and I'm going to do the same now for 102 and 103. Now that has then configured those static routes. Okay, so we've configured R6 to have its router ID. We've also configured it to have the interface IP address, but does it have connectivity? So if we do, that's the first thing we want to test. So let's do run ping. This is the same way as saying in the Cisco world do ping. I want to do this command. I want to run this command, i.e. ping in the Junos world. Run ping 10.0.1.5. Do we have connectivity? We absolutely do. That's always a good thing. Let's also check if we have built the OSPF neighbor adjacency. So let's do run show OSPF neighbor, and it is absolutely there. It's full. So let's summarize where we are right now. R6 has got adjacency with R4. It has built the adjacency. It can ping. If let's also have a look at the OSPF database. Has we got the OSPF entries in the R6 database? So let's just look at the database, and you can actually see that everything is there. In terms of area 2, we could see the R2 LSA router LSA, we could see the R4 router LSA, those type 1 LSAs. We could see the router type 1 LSA that we're advertising. We could see the type 2 network LSAs. We can also see the type 3 LSA. Now this is important to test for end-to-end connectivity. So if I just do quickly a run ping, can I ping into area 3, i.e. the Gigi 0/0/0 interface on R3? So let's do run ping 10.0.2.1, and we have got end-to-end connectivity from R6 all the way through area 0 into area 3. That is absolutely perfect. And just to finish that summary, R6 has built the adjacency. It's got end-to-end connectivity. The OSPF database is of course full from all the entries. We're not filtering anything out, but we haven't configured the OSPF protocol to import these static routes yet. These have been configured, so if I just do a run show route, we can actually see the 192.168.101.102.103.0/24 networks, as I showed, are actually set to reject. So we will get an ICMP response when we ping it from anywhere else in the network, but they're there in the routing table. But if we actually just come on to, let's just look at R2, if I just drag it over here. So here I've logged onto R2, which is the ABR between area 2 and area 0. And if I do a run show OSPF database, can you actually see those external LSAs, those type 5 LSAs? The answer is no. For area 2, there are no external summary or external LSAs, those type 5 LSAs. And that is because the default behavior on Junos devices is not to automatically advertise everything into OSPF. Yes, the entries might be there in the routing table. That's great. But you don't want OSPF to suddenly take those routing entries and just automatically advertise that into OSPF, into the LSDB, and then share that with all other routers in that same area. That's not really the best behavior. So the default behavior on Junos devices, on Juniper EX, QFX switches and MX routers, etc., is actually you need to configure a policy which is going to export those static routes, export them from the routing table and inject that into OSPF. And that's what we're going to do right now. How do we do that though? Well, first is just do edit policy options. So here I've just navigated into policy options. This is the same thing as doing an ACL prefix list, whatever it may be in the Cisco world. But here it's just called policy options. It's nice, simple, straightforward, but you still get that same granular control. So here we're just going to keep it simple though. So I'm going to set a policy statement and I'm just going to call it export static, because I'm exporting static routes from the OSPF and I'm going to bring that into the OSPF routing protocol. You need to give it a term. I think we can all understand why terms, so you can add more terms as you might want to evolve or configure, modify the policy options as policy statements, as time progresses. So term 1. Now here we need to say from, and if I just do a question mark, we can see you could do quite a lot here. So from EVPN, from a particular family, from a particular another policy, etc. But here I want to say from protocol static. So all static routes. Okay, you can do more than this, so we can filter it out to be more specific, but here I'm just going to say set policy statement export static, that's the name, term 1 from protocol static. I then need to say from protocol static then accept. Okay, and if I now just do a show, we get a summary here of what we've just configured. So first I've just created the policy statement called export static. I gave a simple term 1 from all static routes which are in the routing table, I want to accept that. As I said, it's going to be straightforward for this lab. You can make it more specific, of course, and you want to have more specific terms before you get very vague definition like this. You might want to say term 1 from all protocols UDP or TCP from this particular subnet. So you might want to filter out on a particular subnet like 192.168.102. We might want to reject that but accept everything else. You can do that, of course. But here we are just going to say accept all static routes. Now that's that policy defined. Great. But we now need to bring that into OSPF. So if I now say top, I want to go to the top of the tree, edit protocols OSPF, coming down to another branch. Let's do show, and you can see again there's nothing really set here, so I'm just going to do set export and the name of that policy option, that policy statement that we defined up here. And if I now push commit, well, not commit, I push return. And now if I do a commit, but before I do that, just to refresh you, if I bring up R2 again and just move it over, note here for area 2 there's no external LSAs, there's no type 5 LSAs. Okay, that's fine. But if I now do a commit, we are going to commit that configuration from that candidate database into the running database into the running configuration. Now if I just do the same command again on R2, we can now see those type 5 external LSAs on R2, because R5 has said yes from that type 1 LSA, that router LSA, yes, I'm an ASBR, but until you configure that policy statement to say these are these routes, these protocols, or whatever it may be, I'm going to inject that into OSPF with these metrics, with these next hops, with discard or resolve, retain, whatever it may be. There's loads of different options. Then OSPF is not going to do that. You need to define that policy statement and set it as export or import in the OSPF routing protocol. That is just the default behavior of Junos devices. But on R2 now, if I don't need R6 anymore, so let's just minimize this and drag this over. So if I now do run show OSPF database, and let's look into more detail on the external LSA, and let's give it a LSA ID of 192.168.101.0. So I want to look into that particular LSA. And now we can see, remember at the beginning of this video I said the type 5 LSA is going to give the advertising router. So we can see that on this type 5 LSA we can see R6 is advertising this 192.168.101.0. We can also see the mask, i.e. a /24. We can also see the type, so we know this is a type 2, i.e. it's an E2. And the metric, the cost to get to this particular network itself. Now there's a reason why it's set to metric 0. Yes, you're probably wondering, well, hang on, the cost here to get from R4 to R6, surely that would be 1. And yes, you are correct, but this comes down to that type 2 cost and the difference between an E2 or type 2 and an E1 or type 1 respectively. Again, there'll be another video on that coming up. Okay, we can also see forward Juniper and a tag, all the different things you could do on the policy statement. But the real question is now, and the question for yourselves is, R2 is seeing this in its LSDB within area 2. We could see that type 5 LSA. Is that type 5 LSA then going to be advertised all the way through to area 0, onto R1 and even into R3? Will we see that type 5, that external LSA? Let's have a look. So if I bring up just R1 here, and let's actually just check that we've got connectivity. So I just want to do a run ping 192.168, and when I say connectivity I don't mean end-to-end connectivity, I mean can we actually ping those external LSAs. So here I'm going to ping 192.168.101.1 just for example, and here you can actually see we're getting an ICMP response. That is because I defined on R6 to do reject. If I had to set it to discard, it will just drop the packets and not send an ICMP response. And from our point of view, we don't actually know, well, can R1 get to these networks in the first place? But now I know that I can because I'm getting an ICMP response. But let's stop this. Now let's look at the database. So if I do a run show OSPF database, we can see that we have got the external LSAs for 192.168.101, 102 and 103. Now that's great, and that answers that question. Yes, you will see those type 5 LSAs. Of course, the ASBR R2 is going to advertise out those type 5 LSAs to say these are the external networks connected to me. But here's the but. R1 does not know of R6's existence. It knows the advertising router is 6666, but R6 is in area 2. R1 is in area 0. You can see here that there is no router LSA for R6. So we can see the networks, and we'll be able to see the subnet and the cost and the metric type, E2, E1 or N2, N1, etc. to get to these external LSAs. But how does R1 know to get to, does R1 know how to get to R6? And that is where the ASBR Summary Type 4 LSA comes into it. This entry right up here. What the ABR is doing in the OSPF routing protocol is, on top of that Type 5 LSA, is then going to generate and inject into the adjacent area, i.e. into area 0, a Type 4 LSA, that's Summary ASBR or Summary Autonomous System Border Router, i.e. R6 LSA. And it's going to say, well, if you want to get to R6, you've got to come through me. So now R1 knows, hang on, these Type 5s for all these different networks are advertised by R6, but I don't know who R6 is just by these Type 5 LSAs. But I've got a Type 4 LSA which is advertised by R2 to say, well, if you want to get to these networks which are advertised by R6, well, I've got R6 connected to me. Great. And that is what the Type 4 LSA, the Summary ASBR, actually does. And so in summary, what does the ASBR Type 4 Summary actually do here? First is it will advertise who is that ABR. So now we know that the ABR is not R3 connected to area 3, but it is R2 connected to area 2. It will also tell you the ASBR ID. So we can see that the ASBR ID is R6. And via the Type 5 LSA, we can see R6 is advertising these external networks, these external prefixes into OSPF. And so now if we do a run show OSPF database, and let's do ASBR Summary detail LSA ID 192.168.101.0, I gave completely the wrong command there. I thought I was doing something wrong. So if I actually run the 6666, virtual machine is going slow. And now we can see into more detail into that Type 4 Summary ASBR LSA. I know it's a bit of a tongue twister, but as I said, we can see the ID. So that is the R6's ID. We can see the ABR that's advertising R6's existence. We can see the metric 2. We could see, so that is the ABR's cost to get to the actual network prefix itself. So one hop here, not one hop, but count of one here, count of one here, because they're both GigE interfaces. So the ABR knows for me to get to R6 through R4, 1 plus 1 obviously equals 2. And we then have the mask for this. So really the Type 4 is complementing that Type 5 LSA. Okay, now the other question though is for yourself is if we come down to R5 all the way down here, what is it going to see as that Type 5 and Type 4 LSA? Is that Type 5 going to remain unchanged, or will it remain the same? Who is it going to see as that advertising router? And now I want you to think about that, because if we look at R5, it's in area 3. Does it know of R2's existence? No, it simply doesn't, because remember, R2 is an ABR to area 0 and area 2. It's not an ABR to area 0 and area 3 where R5 actually resides. So R5 is not going to see that router LSA where I2 is identifying itself and saying this is who I am, this is who's connected to me, these are the network IDs, the subnets and the cost to get to it. It simply doesn't know of R2's actual existence. It does, however, know of R3, because R3 is the ABR to area 0 and area 3. So R3 is sending that router LSA into area 0 and into area 3. And so if we actually look at R5 here, let me just expand the window just a little bit, and if we do a show I'm not doing a run because I'm not in configuration mode. In configuration mode you'd have the asterisk. Here we've got the arrow pointing right, so I know I'm just in monitor mode. So let's do a show OSPF database. Now we can see those external LSAs, those type 5 LSAs. So to answer one of those questions I asked, yes, we can still see those type 5 LSAs. They've been advertised all the way from R6 through area 2, from the ABR R2 into area 0, through to the ABR R3, and then into area 3 where R5 actually is. So we can see those external LSAs, those type 5 LSAs. That's great. Can we ping them? Let's test. Let's do ping 192.168.101.1. Hopefully we see that reject. We see those ICMP responses, so we know the routing is working. But let me just do the run, the show OSPF database again, just to refresh the screen. Note now the type 4 LSA has changed, and that's to answer that second part of the question. And that's why I said R5 does not know of R2's existence. Yes, from R1's perspective, it knows of R2 because R2 is in the same area as R1. They're both in area 0, but R5 is in area 3. R2 is not going to advertise its router LSA to R5. They're in completely different areas. And so what the ABR, what the area border router R3 is doing, is saying, well, yes, I'm going to advertise to you these type 5 external LSAs for 101, 102, 103. Here, the advertising router is again R6, and coming back to what we saw in R1, R3 doesn't know of its existence. So that ABR R3 is then saying, well, if you want to get to R6, you've got to come through me. Okay? So again, the R4 LSA is really complementing that type 5 LSA. Without that type 4 LSA, this simply would not work, because the routers here would not know where to send the ICMP ping to. If you've got multiple ABRs in the area, here's it going to go to that ABR or to that ABR. And here, in this case, it's simple. We've only got ABR3 or ABR2 for area 3, area 2 respectively. And so really, everyone, what's important here is without that type 4 LSA, without that summary ASBR LSA, this really wouldn't work. Because yes, that type 5 LSA is going all throughout the network here. There's no policy options denying anything, filtering it out, just keeping it nice, clean and simple. But from R5's perspective, it doesn't know of R2's existence, because it's not in the same area. R2 is an ABR between area 2 and area 0. It certainly isn't going to know about R6's existence in area 2. And why? Because they're in different areas completely. R5 is not going to see those type 1 LSAs, those router LSAs, which identify who's connected to R2 and R6, what their network IDs, their subnets, their costs, etc. Everything you get within that router LSA. And because R5, and vice versa, and because R5 doesn't know of R2's, the ABR's existence, and even R6, where these external type 5 LSAs are being exported from the routing table into OSPF, that's where that type 4 really comes into it. The ABRs generate that type 4 saying, well, if you want to get to these external LSAs, you've got to come through me. But when those external LSAs then hit ABR3, or R3, the ABR here for area 3 and area 0, it then generated a new set of ASBR Summary LSAs, type 4 LSAs, to say, well, if you want to get to R6, you've got to come through me. I am the advertising router for this ASBR Summary, this type 4 LSA. And likewise, if we go back to R2, we can actually see just up here, it's got the, we can actually see, here we are here, that for area 2, we've got the ASBR Summary just here saying, well, if you want to get to R6, you've got to come through me. And if you look at VMX1 here, this is what I wanted to show. We could see the ASBR summary here, i.e. if you want to get to router R6, I am going to go through R2 because that is the ABR. Okay everyone, so that's the end of this week's video where we went into quite a deep dive into those different OSPF LSA types 4 and 5. But let's just do a quick recap. Type 5, that external LSA. That is where you've got an autonomous system border router ASBR, which is bringing external routes, protocols, static routes in this case, or BGP, RIP, whatever it may be, and it is exporting it out of the routing table but into OSPF, and then OSPF is advertising that, depending on policy options, throughout the entire area and into other areas via the ABR. That is the job of that Type 5 LSA, i.e. to advertise the network ID, the subnet mask, the cost, and that type of metric. Again, there'll be another video on those different metric types. And that Type 4 LSA, that summary ASBR, the summary autonomous system border router LSA, is then used and generated by those ABRs to advertise into other areas, saying, well, if you want to get to this ASBR, you've got to go through me, because I'm advertising who the ASBR is. I'm advertising myself as that ABR connected to that ASBR or within the same area as me, and this is my cost to get to that external to that ASBR in the first place. So I hope you found this video useful, and look forward to next week's video where we're actually going to go into detail again into that Type 7 LSA, and then we're going to start building into more detail into those different OSPF special networks, the stub, this totally stubby, not so stubby, totally not so stubby, tongue twisters. So thanks very much and goodbye.